Hello, this is Professor Barati, ACC 306, and I'd like to just do a quick homework problem that you'll likely see in this week's chapter, my lab, and it's a comprehensive bond payable solution, and I want to walk it through and give you some of the theory behind the entries and what's going on. Bonds payable may seem complex, but they're really not if you take it slowly and one piece at a time. All it is just a word problem, like in algebra. You have to sort through the information, and each information basically in the problem represents a journal entry. So I'm going to help point that out to you, and take it slow and don't panic. And bonds are basically a little more complex than stocks, obviously, and there's a lot more going on. So a bond payable, to be short, corporations or companies issue bonds to raise capital, to raise cash. Whether it's usually for long term, whether it's to finance an acquisition of another company or to build a plant or warehouse. Bonds usually have long maturities. They're longer term in nature, so they are on the balance sheet as a long-term liability. However, we do classify the principal and interest for a 12-month period in the current liability section, as you've learned going through the chapter. So basically, bonds are debt instruments. We issue bonds and we get cash. In return, the debt holder or the bond holder will get an interest payment from us. Usually it's semi-annually, every 6 months, and along with a principal. The bond payable uses an effective interest method, which I will go through, and all that is basically recording interest at the coupon rate, but actually giving the market rate. So let's walk through this problem. On January 1st, 2015, the Tracy Clothing Corporation issued $1,300,000 par value at 5% 6-year bonds. Interest is payable semi-annually each January 1st and July 1st, with the first interest payment due at the end of the period on July 1st. The market rate of interest on the date of the bond was 6%. Bond issue cost is $72,960. So we're going to issue a bond to raise $1,300,000 par value. And par value is usually similar, just like what a stock is, par value. We assign a par value, a face value, to a bond on our books. Usually it's $1,000 per bond, or it's quoted on the stock market as $100 par value. So the par value is the amount or the value we assign the bond on our books. We're going to have a coupon payment of 5% semi-annually for 6 years. So we're going to pay the people who invest in our bonds a 5% per year interest payment. The market rate of the interest on the date of the bond was 6%. This is very relevant to us because that 6% is really going to be the effective interest that we're going to have to pay. When the market rate is greater than the coupon rate, what it's telling us is that we are not paying the interest that the market will bear. We're offering a lower interest than what the market is. So our debt holders can go into the market, the bond market, and get bonds equivalent to ours for 6%. So why would they buy our bond that gives them 5%? They won't. And that's why we have a discount on bonds payable. What will happen is when we issue our bond in the market, we will have to discount the price of our bond in order to entice people to buy it. And that discount essentially represents the additional interest that we will have to pay, hence the effective interest rate, not the coupon rate. Conversely, if our bond offered 6% coupon, but the market rate was 5%, that means we are paying more than the market. Therefore, if the bondholders want to go into the market and buy an equivalent bond, assuming other things being equal, such as credit rating and so on, they would actually fare worse. They would want to buy our bond because we're more generous with the interest. And therefore, in the market, when that bond is issued, bondholders would be willing to pay a premium for our bond. That premium is outside the par value. That premium is basically reflects a reduction in the actual interest that we would have to pay. And therefore, effectively, our interest would be lower. But in this example, our 5% coupon is less than our 6% market rate. Therefore, we're going to have to discount our bond. So, when this happens, and it's very common, where the coupon rate does not equal the market rate, we have to use the present value tables. We have to find the present value of our bond and record it accordingly on our books. So first of all, what you want to do is organize the key information. 1. We know that the issue price or the par value is $1,300,000. The stated interest rate or the coupon rate that's on the bond is 5%. It's payable semi-annually on January 1st and July 1st. Very relevant because that's going to affect how we do present value. We're going to have to adjust the number of payments, as you know, and the interest rate. The market rate is 6%. That's what's relevant here. And we have bond issue costs of $72,960, which essentially bond issue costs are the cost we pay investment bankers to help bring our bond to the market. So the bond issue costs are essentially going to be amortized as an expense over the period of the maturity of the bond. So step 1, determine the issue price of the debt. This is essentially determining the present value of the $1,300,000 bond. The present value in this case is $1,235,299, and we compute that using our present value table. 1. Calculate the semi-annual interest payment to plug the payment on the Excel present value table. So the interest payment is $1,300,000 times 5%, which is the coupon rate. That's the interest rate we're going to pay the bondholder. We divide that by 2 because we pay it twice a year, and that equals $32,500 semi-annually. So our interest payment is going to be $32,500 semi-annually. So step 1, calculate the semi-annual interest payment to plug into the payment section on the present value Excel table. Use the coupon rate. Now, what we use for a rate is not the coupon rate, it's the market rate. So for the rate, we're going to use 0.03 because it's stated that the market rate is 6%, but as you know, in present value tables, if it's semi-annually, you divide 6% by 2. If it's quarterly, you would divide 6% by 4. So in this case, semi-annually, so if we are basically paying 3% semi-annually. The number of periods that you plug into your present value table are going to be 6 times 2, representing 6 years times 2 semi-annually equals 12 periods. So we're converting years into the actual number of payments. So we're going to make 12 payments at 0.03, 3%. In the payment part of your financial present value Excel, you're going to take that same $32,500, which I've shown you how to calculate, put it in as a negative because it's a payment, outgoing cash flow. The face value or fair value we must pay when the bond matures is a negative $1,300,000. So when that bond matures in 6 years, we have to return the face value, which is $1,300,000, make that negative because we're paying that out. So the two dollar amounts in your present value Excel spreadsheet are going to be negative $32,500 for interest payment and minus $1,300,000 for the fair value of the bond. That will give you a present value of $1,235,299. So that bond, that $1,300,000 6 years from now, in its present value is $1,235,299. Prepare the amortization schedule table for bond issued. So we're essentially creating an effective interest table. Very important. The carrying value of the bond is $1,235,295, which is your present value. We are calculating the effective interest, which is 3%, which is given to you right in the problem. So B is calculated by taking the carrying value, which is the present value, multiplying it by 3%, which gives you $37,059. The actual interest payment is $32,500, 5%, which we calculated right here. That stays constant. Every 6 months, we're paying out $32,500. But the actual interest, effectively, we're paying is $37,059. The difference between B and A is going to be $4,559. That's going to be our discount. So we make this calculation in year January 1st, 2016. We take the new carrying value, which is going to be the $1,235,000 plus the discount. We're going to take 3% of that again and get $37,196. Notice that the carrying value increases every year because essentially we're amortizing the premium and we're getting that carrying value to increase by that amount. So the $1,235,299 plus the $4,559 equals $1,239,858. Take the effective interest rate of 3% of that, and you get $37,196. Subtract that from the $32,500 and your discount is $4,696. And so on. Follow this schedule. The 4559 plus 4696 plus 4837 plus 4982 plus 5131 plus 5285 will equal the amortization of the discount. Step C, prepare the journal entries necessary to account for the bonds the first year. So we issue our bonds at the present value. Hence, our cash, notice the $1,235,000, which was our present value. I rounded it here. I didn't put in the $299, but that's what you would use is $1,235,299. Subtract the $72,960, which is the bond issue cost, and that would be the cash that you actually get. The bond issue cost gets put on the books as unamortized and will be amortized every period. The bond is always put on as a liability at par value, always, $1,300,000. So the difference is our discount on bonds payable of $64,701. So the discount represents the effective interest that will get amortized. Let's record the first semi-annual interest payment. Do not record the semi-annual entry to amortize the bond issue costs. So, the first interest payment is right in your schedule, $37,059 is your first interest payment. But that's the interest we are recording as the effective interest. That's not the actual payment. The actual payment is the $32,500, which is the coupon rate. That is the amount we are giving to the bondholder. So we're crediting cash. We're physically giving them $32,500, which represents 5% coupon on the $1,300,000 divided by 2. $3,705 is essentially the interest that we are recognizing as an expense, because that's the effective interest, which takes into consideration the market value, the market rate of 6%. So our interest expense is actually higher than our interest paid because we are using the 6% effective method to record interest expense. Discount on bonds payable is right here in your schedule, the $4,559. It's being amortized. So we book $64,000 as a debit, which is a contra liability. That $64,701 now is being amortized by $4,559. So the discount decreases. Because this is a contra liability, which reduces the carrying value, gets netted against our $1,300,000 bond payable, because our carrying value goes up, that means our bonds payable basically will be netted down. The bond issue expense is simply the unamortized bond issue costs spread out over the 6-year period divided by 2. Now, to record interest expense the following period on December 31st, the second semi-annual, the interest expense is right here in your schedule, $37,196. The payment is $32,500, and the discount again is right from your effective your effective interest payment of $4,696. So notice that these columns basically represent journal entries. Credit cash, debit interest expense, credit to discount on premium, the discount amortized. These three columns represent your journal entry. Record the semi-annual interest payment on January 1st. On January 1st, we have to record an accrual because we are not paying it yet on January 1st. So we have to record a semi-annual interest payment on January 1st to record an interest payable and credit cash. We're making a payment for cash. We're debiting interest payable on January 1st. Prepare the journal entry to record the interest accrual and amortize for year 3. Then on December 31st, 2017, we're going to recognize our interest expense for $37,785 at the end of the year. So our journal entry jumps. We're going to credit our interest payable, and we're going to credit the discount. Again, we record the bond issue costs. And then we do a semi-annual interest payment on January 1st for 2018 for the same amount. When the bond matures, we pay our customers $1,300,000, so it's a credited cash, and we debit the liability for the full maturity of $1,300,000. That essentially is a straightforward bond payable problem, which is in the canvas, which you can click on and walk yourself through the problems quickly and follow these steps. And they're basically consistent with most of these bond payable problems. Thank you, and enjoy your evening.